Hello everybody! Today I can find an equivalent exponential form by absorbing the exponent or setting the two expressions equal to each other. So there's two types of questions that you're going to see today. One, we're going to absorb the exponent, and the other one, we're going to set expressions equal to each other. That's when we're dealing with E. So let's just start with the first type of question here. And here we go. Express each of the following functions with an exponent of t, round values to the nearest thousandth. Well, I want just t in the exponent. I have 12t. So I'm going to absorb the 12 into the parentheses. So it becomes 1.025 to the 12th to the power of t. Because remember, when we raise a power to a power, I multiply the powers. So if we're going in the opposite direction, when I multiply 12 and t, I would get 12t. So now I'm just going to go to my calculator and I'm going to type in what's on the inside. 1.025 to the power of 12. 1.025 to the power of 12. It said to the nearest thousandth. 1.345 to the power of t. Now, what's great about doing this is now that I have it in this form, I can conclude what the annual, let's say t is years, for example, what the annual growth rate is. Based on this, I know the annual growth rate is 0.35. For 34.5%. So that is a good application of this, which we're going to see in a lesson that's later to come. In number 2, again, I want just t in the exponent. So I'm going to take whatever's with the t and absorb it into the parentheses. So it becomes a equals 25,000, 1.125 to the 13.2. to the power of t. So now I can go to my calculator. I'm just typing in what's inside those parentheses. 1.125 to the power of 13.2. I get 4.734. So very simply what that means is, well, every year it's being multiplied by 4.734. It's quite a big growth rate because I'm adding 3.734, but that's basically the application of that. So it's not very complicated. If you want just a t in the exponent, you just take whatever is with it and you absorb it into the parentheses. Why don't you try 3 and 4 right now on your own? So please pause, try 3 and 4 on your own, and then I'll go over them. Okay, now that you tried 3 and 4 on your own, I'm going to go over it for you. So in number 3, I'm taking that 10 and I'm absorbing it into the parentheses. So it's going to be a equals 37,000.986 to the power of 10 to the power of t. From there, I'm just going to type 0.986 to the power of 10 into the calculator. I get 0.868 to the power of t. So again, this and this are equivalent exponential expressions. What's great about what I just came up with is it's showing me that the growth rate, or the decay rate in this case, since it's less than 1, is about 13.2%, because that's what I would subtract from 1 to get the 0.868. Number 4 I asked you to do as well. If you didn't already, you can pause it now and give it a try. I'm going to take whatever's with the t, I'm going to absorb it into the parentheses. I'm going to type that into the calculator. 0.889 to the power of 9.4 is 0.331. And again, the application of that, now that I have that, I know that the annual decay rate is 33.1% is what's keeping, so it looks like it's going down by 66.9%. So that's my application. And again, if you're wondering where I'm coming up with that with, if I just did 1 minus 0.331, that will tell me the decay rate 0.669 or 66.9%. All right. If it's a fraction, it's the same type of thing. I'm actually going to skip that one. Let's just take a quick look at 7. If I wanted to absorb 7, well, what's in front of the exponent? 1/12 is in front of the exponent. So when I'm absorbing it, 11,185.764 to the 1/12. See. So if it's a fraction, we would just do what we normally do, and if it's t over something, then there's a 1 in front of that t, and you're pulling the whole fraction in. 0.764 to the power of 1 over 12 is 0.978. So again, this is just an equivalent exponential expression to the original, but this one's valuable because now looking at this, I know that the decay rate is about 2.2% because 1 minus 0.022 would be 0.978. Why don't you try number 8 on your own right now? So please pause, try number 8 on your own, and then unpause. Okay, I am absorbing 1/4 into the parentheses. So I do 0.785 to the power of 1/4, and I get 0.941 to the power of t. And again, the application of that is that I know now that if t is years, that the annual decay rate is 1 minus 0.941. Sorry, I can't really talk right now. 1 minus 0.941, which means you're maintaining 94.1%, which means you're losing 5.9%. All right, so that's basically it for the first type of question. I can find an equivalent exponential form by absorbing the exponent. So if you have something with the t and I want to get rid of it, I just absorb it into the parentheses. That's the same type of thing. That's the same type of thing. No, this is not the same type of thing. So this is the second type of question. The population P of t of a small county in western New York has grown according to the formula P of t equals that. When rewritten in the form P of t equals 6,000 e to the RT, what is the value of r rounded to the nearest thousandth? Well, if you look back at the aim, setting the two expressions equal to each other. If I want equivalent forms, and it's telling me the equivalent forms, then I'm going to set the expressions equal to each other. So it wants me to solve for r. The first thing I'm going to do here is I'm going to divide 6,000 on both sides, and that's gone. So I get 1.392 to the 1.2t equals 6,000 e to the rt. Now I am solving for, it wants me to solve for r, so I am going to isolate, divide both sides by 6,000. That's going to give me 1.392 to the 1.2t over 6,000 equals e to the rt. Now, to solve an exponential equation, I'm going to take the log of both sides. Since it's e, I'm going to do ln of both sides. So I'm going to get ln 1.392 Oh, I just realized I made a mistake. I was wondering why something wasn't working out. So these 6,000s canceled. So I just have, here, let me just erase. Something doesn't make sense here. So let me just bring it back here. So when I divided both sides by 6,000, those canceled and those canceled. I'm left with 1.392 to the 1.2t equals e to the rt. So now I'm doing my ln of both sides. So I get ln 1.392 to the 1.2t equals ln e to the rt. The reason I do that is to get my exponent in front. So I have 1.2t ln 1.392 equals rt ln e, and remember ln e just cancels. I can divide both sides by t, and the t's are gone. I get r equals 1.2 ln 1.392 1.2 ln 1.392. I get 0.3, and what's the nearest thousandth? 0.397. So what was my procedure? I set the two expressions equal to each other, 6,000 1.392 to the 1.2t and 6,000 e to the rt. I then divided the 6,000s away. They're gone. Once I have that e to the rt, again, I'm solving for r, so I do the log of both sides, or because it's e, I do the ln of both sides. When I do that, the exponent comes in front. ln e cancels, because ln e always cancels. I divided the t away at this point, and then I had my answer. Number 11, I've got v of t in this form. It wants v of t in this form. What would be the value of r rounded to the nearest tenth of a percent? So I've got 10,000.875 to the 1.04t equals 10,000 e to the rt. So I want to solve for r. The first thing I'm going to do is I'm going to divide by 10,000. I get 0.875 to the 1.04t equals e to the rt. Next, I'm going to do ln of both sides, since it's an e and it's an exponential equation. So I get 1.04t ln 0.875 equals RT ln E. I don't have to write the ln E since it cancels out. I divide by T. T's cancel, R equals 1.04 ln 0.875. I go to my calculator at this point. 1.04 ln 0.875. I get negative to the nearest tenth of a percent. So for now, let's write negative 0.13 dot dot dot. Because it wants it as a percent, I'm going to multiply that by 100. And I would get to the nearest tenth of a percent, negative 13.9%. Interpret the meaning in the context of the problem. Well, because it's negative, it's decreasing by 13.9%. What is the value of the investment? So let's just type this out. The value of the investment is decreasing by 13.9% each year. Whoops. I guess this guy should probably pick a different thing to invest in because he's not doing too well. All right. We got just a couple more. Number 12. It's giving me this equation. It's giving me this equation. It's asking for K. So I'm going to start by setting them equal to each other. So I want you to try this one on your own. There's a little algebraic twist at the end. Hopefully you know how to get rid of a fraction. So please pause, give this a try on your own, and then unpause. Okay, now that you tried this on your own, let's do it. I will go over it for you. 100, 1/2 to the d over 8 equals 100 e to the kd. I'm going to divide the 100 away. That's going to give me it's going to give me 1/2 to the d over 8 equals e to the kd. Now, ln of both sides. That's going to give me d over 8 ln 1/2 equals kd. Now, I hope the fraction isn't really, if I just divide away the d is gone, and I'm left with k equals ln 1/2 over 8. So now I can go to my calculator and I can type in alpha y equals enter ln of 1/2 over 8. And it wants it to the nearest, well, it has the choices, the nearest thousand, negative 0.087 would be the answer. So there's two types of questions in this lesson. They're both equivalent exponential forms. If it's giving you two forms and they want a missing variable, you set them equal to each other because they're equivalent, they're equal. If they want just a t in the exponent, then you absorb whatever's with the t into the parentheses. Your classwork/homework is to finish this worksheet, and we're going to build upon this in at least the first thing on this lesson in the next lesson. Have a great day.